So anyway, again, my name is Ryan Jones, one of the application engineers here, joined as well by Anthony Nicolaitis. If you guys have any questions or if there's any technical difficulties, please just type into the chat window, and Anthony will do his best to answer. So welcome again. We're here to talk about the Jazz series of PLCs that we offer. The Jazz unit is one of our introductory level PLCs. We try to keep the cost as low as we can while still giving our a full rich catalog of features. The Jazz still has some onboard I/O capable of digital, analog, relay, and transistor outputs, as well as thermocouples, depending on which Jazz unit you select. It can still do high-speed inputs or a high-speed counter. Like all our software, you can download it for free. The Jazz is based off of our U90 software platform that our M90 and M91 series of controllers uses. It came out before the Vision products, so it is a bit different. We'll get into that more when we look at the software. If you're used to programming on our Vision controllers, you should be right at home. Things are just going to be a little different, but overall pretty similar. We have 24K of virtual ladder code memory. We're capable of using the GSM modem as well as SMS. And we can still use some remote access utilities, so we can remotely access the data as well as the HMI screen remotely. The HMI itself is a 2-line 16 characters. We can have up to 60 different screens. We also support multi-languages as well as graphics, pretty simple graphics. We can display conditional messages similar to a bitmap or an image by pointer. We can have, for instance, if there's an alarm, we can have the screen, depending on which alarm is currently active, displayed on the screen. We can show time, date, bit status, status of any timers, integers, any data that we have in the controller we can link to the HMI. And it also is a lit screen. Like I said before, even though it is designed to be our introductory model, it's still feature-rich. It has a alphanumeric keypad on it that's customizable. You'll see there's little tabs that can slide in and out depending on what you want the buttons to read, and then you could program in your ladder how they function. You can do a full source upload, similar to a burn and upload project, so we can get the program from the controller at a later date. We're able to use high-speed counters. In the picture here, we see a flow meter. We can have time-based control. Depending on the value stored in the real-time clock, we can have different operations run and for a certain amount of time. We can use the HMI to scroll between pre-programmed recipes or menus. We could have multiple jobs or recipes on the same controller and basically just be able to switch in between the two right from the HMI. Like I said before, it is multilingual. The default is English characters. We can change it to any other character-based language as well. We offer the program cloner. I'll talk about that a little bit later. Basically just allows us to clone one Jazz unit to another. And we can also print from the Jazz. There's a couple different Jazz models. I'd recommend you, if you have a copy of our catalog, or to go to our website, Unitronics.com, click on support and go to our technical library to see the most up-to-date specs for all our models. The Jazz, although it has onboard I/O, it is not compatible with our expansion options. For example, our EX82X, our local expansion adapter and I/O modules are not compatible with the Jazz. So just keep that in mind when you're selecting which one you need. You're probably going to want to get more I/Os than you currently need, just so that if down the road your project expands at all, you'll be able to accommodate for that. The Jazz actually does not have a built-in serial port like our other models. This was done to kind of slim down the package as much as we could, pass the savings on to you basically. So you have a couple options of how you can program it. The first is the basic programming kit. Just a module snaps right into the side of the Jazz unit and then connects over serial to your computer. We can download programs. The great thing about this is if you are, let's say we're programming 15 different Jazz units, all of the same program, we don't have to buy a programming kit for each one. We only need one programming kit to program one at a time. If you want a full-fledged RS-232 or 485 port, say you're going to be using a barcode scanner or a printer or communicating over Modbus, we do have an added module, the JZRS4, and you can also use that to program as well. And the third option is the program cloner module. It's the MJ20 MEM1. Basically, if you've done an SD clone, it's kind of the same principle. Basically, we can install the module into a Jazz unit, download the entire the OS, data tables, any operands, download all that information into the cloner module, take the module out, plug it into a separate Jazz, and download all that information into the new one. And the keypad slide kit as well. So today we're going to cover the basic U90 interface. I'm going to show you where to find all the different buttons and features. We're going to show how to update the OS on a Jazz, as well as establish communication. I'm going to show you how to download a program. We're going to create several different HMI screens. We're going to link some variables to that HMI. And I'm going to show you how to use the keypad entry, so how to enter a variable from the front of the unit. We're going to use what we call an SB function to linearize two values. I'll talk about that a little bit more when we get into the U90 software. And we also are going to go through an SI function to fill a vector. So let's go ahead and open up the U90 software. So if you're familiar with VisiLogic, this will look relatively similar. You'll notice there's one screen for the ladder, and we have one screen for the displays. The first thing we're always going to want to do whenever we start a new project is we're going to want to confirm our communication settings, as well as check to see if the OS is up to date. So in U90, what we're going to do is we're going to go to Controller. We're going to Operating System. Select the right COM port. This COM port is assigned by your computer to wherever the programming module is plugged into. In my computer, it is COM1. And I'm going to set the communication speed to the default, which is 9600. Go ahead and hit Check Current OS. And it says my OS is up to date. If it was not, I would see over here in the operating system, this drop-down is going to have all the OS files available that I could download. I could select which one I want. Then I could hit Start to download. Since we're all up to date, we're just going to close that. Okay, so I know my controller is up to date, and I know my communication's okay. So let's go ahead and start a new program. So I'm click New. We're going to be using a Jazz controller, and I have a JZ10-11-R10. You'll see here, I can define any of the inputs, outputs, and it has two high-speed inputs. We're actually not going to be using any inputs today, so I'm going to leave them all blank. And go ahead and hit OK. And that's it. We're ready to start programming. I want to go over just a few more of the U90 features. You'll see over here on the left, this is our navigation pane. Starting with the properties, we can set up the author, manager, we can set up some comments, perhaps keep a history log of any changes. We can also see the statistics. This is a great tool, especially for larger programs where you might be reaching the maximum size for memory allocation in terms of the program or the HMI displays. This is a great little indicator of how much we've used so far. Next up, we have the program. Quick jump to the ladder. The power up, if I have assigned any power up values to any of my operands, meaning that as soon as the controller powers on, it's going to assign those values. They will be listed here. Since it's a blank program so far, there's not much to look at. Bookmarks, it's a great feature if you have especially for a longer program. Basically, all it does is no matter where you are, what net or what rung you're on, you can create a bookmark. And anytime you select that bookmark, it's going to jump right back to where you were. Again, this is going to be a relatively simple program today, so I'm probably not going to create any bookmarks. So I'm just going to minimize that to keep it out of the way. Next up is our HMI, all our current displays, as well as the variables. Here's a typical blank display. I'll get that in just 1 second. Next up is data types. If I want to see the status or the labeling or value of any of my inputs, outputs, memory bits, etc., this is the window to go to. Basically, this comes up in list form here. If we were in online test mode, we'd be able to see what the current value in the controller is. Next, we have watches. Watches are a great way to track a certain process inside the program. For instance, if I was doing a math function and I just wanted to see the status of all the operands involved in that one function, I could just add them here as a short little list to see them grouped together in one spot. And then lastly, we just have our tools. Hardware configuration we just saw, and then the rest we have modem services, SMS configuration. We don't have to worry about that just yet. It's a little more advanced stuff. Operating system, if we want to run a PID loop or set up a drum, these are just quick links to get us to the right page. So let's go ahead and set up our first HMI. First thing we're going to do is just label it. I'm going to call it main page. And the first thing I'm going to want to add here, real simple, we're going to add a clock in the upper right-hand corner here. First I'm going to label it. You'll notice I can just click anywhere on the screen I want to start typing, and I can just start typing. I'm going to write in time. Now to set a variable, the first thing we have to do is actually create it. So you'll see up here, add new variable. I'm going to call this current time. And I'm going to select the date and time option. It's going to ask me which format I want to use. I'm actually going to stick with the hour-minute format. And then I'm going to go back to my display. So you'll see here is the variable I just created, date and time. I can now select a place to put it. I'm just holding down the left mouse button here. Now since I selected hours and minutes, so that's 2 characters for the hour, 2 characters for the minutes, and 1 character for the colon. So I'm actually going to have to map out 5 character spaces total. So I'm just going to count from right to left. 1, 2, 3, 4, 5. And I can click attach variable. You'll see here be listed as VR. I can just hit the drop down, hit current time, and hit OK. You'll see it kind of appears as these hash marks. They're going to go in order by color. So the first one's going to be red, the next one's going to be green, the third one's going to be blue, etc. And the one here relates to the variable list over here. Not that because it's red, it's because it's variable number 1. So let's actually just go ahead and download that real quick. To download, just this button here. You'll see there's a couple options here, but they're all grayed out. That's because that's actually an M90 feature. With the M90, we can select if we want to download the ladder, the displays, variables, etc. That's actually not available in the Jazz. It just downloads it as one big chunk. So we're just going to go ahead and hit OK. There's our status window. And that's it. So now let's go ahead and see what the time format looks like. So if I go up here to debug, this is what we commonly refer to as online mode. We see this basically virtual representation of the Jazz unit on my desk here. If we had a keypad entry, we could use these buttons, as you see, just like if I was pressing on the unit itself. But there we see time just as I wrote in it, and the time over here. Close that for now. Get off online mode. All right, next we're going to show how to do a bitmap, or a bit. So we're going to say we're going to have a variable on the screen, and when we press the 0 key, we're going to cycle between 2 displays, or 2 elements. So let's say press 0, 2. Now I'm going to have this say start and stop, and it's going to cycle in between the 2. So the first thing we need to do again is create that variable. This is going to be called start stop. It's a bit value. So when it's 0, it's going to say stop. And when it's 1, it's going to say start. If I just wanted to show the value of the bit, all I would have to do is just put in a 0 for the 0 and a 1 for 1. If you just leave it blank, it will not show 0 and 1. You have to enter them in yourself. Let's stick with stop and start. The next thing we need to do is we need to link it to a bit. So we just hit this link to button. You'll see it goes to the first one available, MB0. I'm going to give it a title. We'll call it a run bit. Now, you should notice that MB0 has a label, run bit, and the variable has a separate label, start stop. Start stop is not linked to MB0. MB0 for a description, MB0 has a description run bit. Reason being is we can have multiple variables linked to the same bit or integer and display them in different ways. So, for instance, if we're sticking with this MB, I could have one variable that says stop start, and I could have another variable that says something else. So I'm going to go back to my HMI, just like we did before. Attach variable, and we see it in the dropdown. Again, here's our list. Shows us that the green one is my start stop bit. Okay, but now we need a way to toggle in between start and stop. As is, we don't really have a way to change that bit. So I'm going to go into the ladder portion now. You can click on it over here, or if you like, you can use the link up here as well. All right, we're going to run this bit off of the 0 key on the keypad. So the first thing I'm going to do is I'm going to drop a positive transition contact. All our contacts are under here. I'm going to link it to a system bit. And I'm going to just use the drop down to figure out which one is button 0. So I'm just going to scroll down. And it's SB40, key 0. So when I press key 0 on the keypad for one scan, this variable is going to be high. Now I want this to be able to toggle back and forth. If I just wanted it to change it to 1, turn it to start, I could just put a set here. But I want a way of having it toggle back and forth. So I'm going to create a basic toggle element here. It's rather simple. Basically, I'm going to say have an inverted contact here, and MB0. Basically saying if MB0 is not on, set it. In parallel to that statement, I'm going to say if it is on, reset it. So again, press the 0 key on the keypad. So you can go high for one scan. It's going to check and see if MB0 is running. If it is not, it's going to turn it on. If it is, it's going to turn it off. Let's go ahead and download that. So here we see right now the state of MB0 is currently 0. So it says press 0 to stop. I press 0, and it changes to start. Press it again, goes back to stop. If you see here as well, if we follow the ladder, we can see what's being energized. So when I first hit the SB0 key, this lights up. You see that MB0 is high, and it reset the bit. Toggle it again, and now we see that it's low, and it's set the bit. Now, if we go back to our HMI screen, we see we've kind of filled up all the space. It's not a whole lot of room to play with, so we're going to have to make a new screen. So just click Add New Display here. In this one, we're going to enter the value of 2 MIs. So I'm just going to call it keypad entry. But now we need some way to get to this screen. So real quick, I'm going to go back to my main page. You'll see down here we have the jump conditions. I'm going to create a jump condition. Again, I'm using a system bit because I want to link it to the arrow key. Whenever I press the right arrow key, I want to jump to keypad entry. And similarly, once I'm on keypad, I need a way to get back. So I'm going to just do the same. Set a system bit. to the left arrow key. And let's move back to my main page. Okay, so like I said, on this screen we're going to enter two MIs. So this is going to be MI0. This is going to be MI1. So we need to create the variables. You go to integer. And you'll notice, depending on which variable type you select, the screen here is going to change. So for bit, we had the text for off and on. For integer, it's going to ask us the format. I'm linking it to MI0. The format here, these X's is the decimal notation. So for instance, xxx.x would be 3 whole numbers and then 1 decimal point. For the first one, we're just going to do 1 decimal. Leading zeros, if we define the MI to take up, let's say, 5 characters on the HMI, if we select the leading zeros option, even if that MI is only 1 character, it's going to fill the other 4 empty spaces with 0. This is going to be a keypad entry, so I just have to check this box. If I want to be able to limit the user to only be able to enter a certain range, I could click Enable Limit, and then give them a minimum maximum value. But for now, we're just going to have any. I'm going to label my variable MI0, no decimal. And we'll write it. We're just going to go ahead and create the MI1 as well. And this one actually is going to have a decimal. We're going to do the 3-2 notation. So 3 whole numbers, 2 decimal points. It's also going to be a keypad entry. Label my variable. Now we can go ahead and put them on the screen. Oops. Wrong button. Attach variable. Just click from the drop-down. And let's go ahead and download. Okay. So here's the first screen that we have. It's going to press the right arrow. Now on the online mode here, we see the tilde character. On the actual PLC itself, it's a blinking underscore cursor, basically highlighting an area that is requesting a keypad entry. So I can go ahead and enter a value here. Just put in 1, 2, 3, 4, 5, and then hit enter. You see, as soon as we finish the first one, it's asking us for the second one. So I'm going to put in 5, 6, 2, 3. Oops. 1, 2, 3, 4, 5. Now you'll notice MI0 and MI1 actually both have the same value right now as stored in the controller. They're both 1, 2, 3, 4, 5. The difference being is MI0 is being displayed as a whole number and MI1 is being displayed as a decimal. But in terms of the actual variable, I'll show you if we go to our MI values here. They both have the same value. It's just how we're showing it on the screen. The Jazz unit actually is not capable of using memory floats. For most cases, that's fine. We just deal with whole number values, basically multiplying by some magnitude of 10. And then when we need to display it on the screen, for whatever reason, we can just put the decimal point in on the HMI. So you'll see the cursor has stopped blinking because I've entered both variables. If I leave the screen and go back, it's going to ask me to enter the variable again. Now with only two screens, that's okay. I can just hit the enter button and it will just store or use the value that was already there instead of taking a new value. For two screens, that's okay. But if we had a larger program, the whole bunch of screens, and we're just trying to get to the one we want, we don't want to have to keep entering all these variables in each time. So there's a way around that. I'll show you how to do that. So we're going to close this. We're going to go to our ladder real quick. Should have had a comment here. This is just toggle MB0 for binary text. And now we're going to prevent keypad entry on new screen 2. So what we're going to do is, first thing we're going to do is we're going to see if we've landed on screen 2. So I'm going to use a compare statement, equal. The current HMI being displayed is stored in an SI2. And I'm going to compare that to a constant of 2. So whenever the current screen changes to 2, I'm going to activate a bit. This is MB1, and I'm going to call it screen 2 displayed. So now whenever I enter that screen 2 that has the MI0 and MI1 keypad entry, I have a bit that's going to go high. What I want to happen is I want that bit to trigger a system bit that we have SB39, which is force HMI entries complete. So instead of requesting the user to enter the values, it's just going to keep whatever values are already there, and it's going to stop the keypad entry. So again, as soon as I come to that screen, I'm setting a bit, or I'm sorry, we're activating a bit. When we first see that bit come on, i.e. when we first come to screen 2, we're going to disable keypad entry. Now that works great when we're cycling through pages to find the page we want, but then we don't have any way of actually entering the data. So we need a way to disable that. So now we're going to enable keypad entry. So again, by default, it's going to enable keypad entry as soon as you go to a screen that has any keypad entry variable in it. We only need to do this because we disabled it. Re-enabling it's relatively simple. I'm going to link it to the enter button. So whenever I press the enter key, I want to be able to enter a new variable. Again, that's a system bit. And what we're going to do is we're going to store the number of the current HMI display into the SI2. I'll explain that in a second. So we store SI2 into SI2. Basically what that's doing is it's refreshing the screen. We're calling the same screen we're already on again. Once we do that, it's going to ask us to put in the new variables. But since our compare statement the bit is only looking for a change, since we're not changing pages, we're just refreshing it, we're not going to set system bit 39. You're right. Good call. All right, so let's go ahead and download that and see how it looks. Okay, so here's our first screen. Now I notice you go over here to screen 2, and you don't see the tilde here. And on my screen, it's not asking me to enter a variable. If I wanted to change the state of MI0 or MI1, all I have to do is press the enter button, refreshes the HMI, and allows me to enter in the variables. Any questions so far? Yes. So SB39, again, is one of the system bits that we have. If we ever set that system bit, it's going to force the controller to complete all keypad entries. So no matter if we've finished entering all the keypad variables on the screen or not, it's going to set them anyway. It's not going to change the values of any of them. It's just not going to prompt us to enter a new value. Again, the main feature of that is we can quickly navigate between screens without having to scroll through every piece of data on each new screen. Anytime we go to a screen that has a keypad entry, the Jazz unit's always going to ask us to enter a value, even if we've already entered a value before and we just are browsing through screen and want it to keep entering it each time. And again, the way we disabled that is just refreshing the screen. Cool. All right, now you note if you're familiar with VisiLogic or other ladder programs, you notice the main difference with U90s, we don't have the function blocks, at least not as many as you'll see in VisiLogic. We still have a lot of the same features and capabilities of the things that you would normally see in a function block. We just have to kind of go about them a different way. For example, we're going to do a linearization. Let's go ahead and start a new screen here. Linearization, basically, we're going to take an input and we're going to find its value on a certain range. So for instance, if we have an analog input, we're reading a bit value, we need to convert that bit value into a real engineering units. Let's say 0.20 milliamps or 0.10 volts. We need some way to scale it. So the first thing we have to do, of course, is add a variable for that bit value. attach the variable. And there's our bit value. And I'm going to show the result of once we scale that bit value to a real engineering value. I'm going to show it in 0 to 20. And the way we're going to do that is in the ladder. It's actually a good point to point out the help file as well as the sample projects that come with the U90. The sample projects is great if you are trying a new feature or programming. If you want to see an example of how it's done, we have a couple folders of different projects you can take a look at, as well as a really good help file. We're going to be doing a linearization. So like I said before, we're going to set up a scale, basically our bit value, the lowest bit to the highest bit, and the lowest real value to the largest real value. So we can take any value in between and see what that comes out to in real units. To do this in the ladder, we're going to be using one of our system bit functions. I just want to show you the help file so you know how to get to it. I'm sure most of you probably can't read within this resolution, but this is where you would find it. Basically what it does is we're going to use the store command. We're going to use the store command to enter the values we want to use for this linearization. Because it's a system bit function, you'll actually see they are labeled here. I believe it begins at SI80. Oops. Sorry. 1 second. There we go. So you see here, starting at SI80, we're looking for the X1 value, the X2 value, Y1 value, Y2 value, as well as our input in the result. Just like if we were setting up a function block, we would set up all our inputs and then define our output. With the system bit functions, they're predefined in system integers. So the first thing I did is I stored 0 because we're going to be using a 12-bit scale, which goes from 0 to 4095. So the low end on the bit side is 0. I'll put in the high end of 4095. And now we're going to go into SI81. They're all labeled, make them easy to find. If you need to, if you know the name, if you don't know the number, you can always type it in the box here. Okay, so now we have the X range, 0 to 495. We're going to define the Y. Again, it's going to be from 0 and we're converting it to a 0 to 20. Okay, so in this rung, we've set up the parameters for the function. Now we need to run it. So the first thing we do is we're going to put in the final input, which is our MI value, MI2. We're going to store that into the SI84, the input. And then we're going to set the bit. Setting the bit is basically telling the function to run. So again, in net 5 here, we've set up the parameters for the function. We've set the x values, 0 to 4095 bit scale. We're converting it to 0 to 20. We've defined our input as MI2, which we're getting from the HMI keypad entry. And then we're activating the function. After that function runs, the output also needs to be saved. So we're going to grab the output from SI85, the result. And we're going to store it in a new MI. We're going to call it 0 to 20 result. Reason being, if we wanted to use this linearization function again, that value would be overwritten. So we're going to save it in a different spot so we can show it on the screen and still use the linearization function. Now we just got to put the 0 to 20 here on the screen, add a new variable. Okay. And lastly, just a way to get back to the screen. Yeah, 1 second. Uh, 52. Anthony actually brings up a good point. Normally, in normal ladder logic, if we're just on the main rung here, if we store a value and immediately set a bit, that bit is always going to be set. We're really not going to have any way of deactivating. For example, if we just put a set coil right here on the rail, it's always going to be activated. There's going to be no way to reset it. However, since it's a system bit, it doesn't follow the same rules or functions as a normal bit. If we store in a value and we set the bit, it's going to run the function once, reset itself, storing the value into SI85, and it's going to wait for a new value. If I enter a new value here, it's going to reset the or reactivate the bit, and again deactivate itself when it's done. When you are dealing with the system bits or system integers, in the help file, it'll clearly define kind of how they function. Just be sure to read it ahead of time. So let's go ahead and download. see what I did. I'll note here, although we're doing linearization in the logic, we can also do it on the display. Basically, we can have the value you want to linearize. You can set up the scale here and display it on the screen. The reason why we're doing it in the logic, if you're doing it on the display, the resulting value isn't stored anywhere. So, for instance, if we needed to convert to a 0 to 20 milliamp signal and then use that in some calculation, we don't have any way of actually addressing the result. The display is only just shown on the screen. Okay, so you'll see here, if we enter 4095, gives us 20 milliamps. If we put in about half that value, it gives us 10. Now let's say we also want to know what it is on a 0 to 10. Okay, so now I want to see what it looks like on a 0 to 20 milliamp. I also want to see what that value would be if we had it configured at a 0 to 10 volt. So in the ladder, I'm actually going to use the exact same SIs we used before. I'm just going to store different values into them. In fact, I'm actually just going to grab this whole rung, actually these 3 rungs, and then hit Control-C on my keyboard to copy them. Press Control-V to paste, and paste them right there. And label them so we can tell them apart. So here's our 20 milliamp linearization. This is going to be our 0 to 10. Now we're using the same bit value, so we don't have to change the X1 and the X2, so I'm going to leave those as is. The bottom scale is the same, so SI82 I'm also going to leave as is, but I'm going to change the upper value of Y2 to 10. We're still converting the same bit value, so that doesn't change, except we're going to store the result now into MI4. Now, we're using the same function, but since ladder always goes from top to bottom, it's going to store in these values for the function, puts in the input, runs the function once, and saves the value. Before running it again, it changes the parameters and then runs it. If we had the activate run before we change the parameters, we wouldn't get the right result. So we can go ahead and download that real quick. So you'll see here, again, it's taking the same bit value, 2040. On a 0 to 20 scale, it's about half value, which is 10. Or on a 0 to 10 scale, it's half, which is about 5. You've taken the same bit using two different, well, the same linearization function, but with two different sets of parameters. So that's a basic system bit function. It's also what we call system integer functions. They function a little bit differently. The best way to see what we have available and how to use them is to go to the help file, searching keyword special functions. And you'll get a complete list of all the ones we have available. We can do A times B divided by C. We can change the COM port parameters. We have a couple Modbus utilities, etc. Just search, take a look in the help file, see if what you're trying to do is there. For each one, you'll see these links in blue. We'll give you a more detailed setup of how they work. The setup for most of them is certainly the same. Basically, what's going to happen is SI 141, 142, 143, etc. Is going to be all our inputs and output. Actually, we're defining where our output's going to be, and then we're going to store the function we want to use into SI 40. So, for instance, A times B divided by C is 100. So after we set up our parameters, as soon as we store 100 into SI 140, it's going to run the A times B divided by C function. If we wanted to use a different function, our input still goes into the same place, SI 141 to SI 146. I believe that's the highest it goes. Only thing we change is the value we store into SI 140. And again, to see what the inputs or how they are set up, just be sure to look at the help file. For our example, we're going to do the fill vector. What we're going to do is we're going to define a vector in our logic that we were going to fill it with the same value. So we're going to take 10 MIs, let's say. We're going to fill them all with one value. So the first thing I need to do, just like we did with the linearization example, we need to store in our parameters. Oops. First one is going to be SI 141. So notice it just says function operand because it all depends on what we store into SI 140. In terms of the fill vector scenario, this is the MI that I want to start filling at. Again, all this information is in the help file. Where is it? So we'll see here SI 141 determines the start of the target vector. SI 142 is going to determine the length. SI 143 is going to select the fill value. And then when we store 100 into SI 40 is when it's going to run the function. So let's just finish setting up our parameters here. I'm going to start at MI20. I'm going to fill 10 MIs. I'm going to store a variable value here. I'm just going to call it store A. So again, I'm storing in where I want to start, MI20, how long, 10, and a value. I'm actually going to give this a power-up value. Let's say 6. So now we have the parameters, we need to set it to run. We're going to do that by storing a value into SI140. Taking a quick look at the help file, determine which one we need. So again, this is fill vector. If I want to fill an MI vector, I'm going to store 30 into SI140. If I was doing an MB vector or a database vector, it would be 36 or 31. But we're just going to do an MI vector, so we need the number 30. So I just go back down to my ladder, store direct, constant 30, into SI140. So setting up my parameters, and then which function to run those parameters with. So I can go ahead and download this to the controller, and we boot it back up. We should see MI20 through MI30 all have the value of 6. I'm going to check quickly just by going to our data types, memory integers, and go into online mode. And there we see MI20 through MI30 has got the value of 6. If I go and I change MI5 here, the value we're copying, say make it 5. Go back to our MIs. See now all has 5. You can use the as many special functions as you want. Just keep in mind, before you run the function, to change the parameters to what you need, and then run the function. I also have this running right on the rail, so it's running every time. If I was doing multiple SI140 functions, I would want to have this on some kind of condition, so I could have a way of delegating when to run which SI140 function. Since I only have one, this works fine. Does anybody have any questions? Cool. So that was a pretty good overview of the Jazz and the U90 programming. If you are interested in any other programming concepts, I do recommend checking out some of the other webinars we have on VisiLogic. Although the programming software is different, things are going to be done a little bit differently, the general concepts are the same. For instance, if you look at our timers webinar, the way the coils and the contacts interact with each other is almost identical. It's just how you place them on the rail, and slight little differences are going to be different. As well as always make sure to check out the help file and the examples folder. Of course, if you have any questions, you can contact us at support@unitronics.com, on our website as well, www.unitronics.com. If you have any ideas for any future webinars or topics you want discussed, feel free to drop us a line. Other than that, thank you all for attending, and I hope you have a great day.